Good morning, everyone. So today we're here to talk about building PowerShell modules and using those in combination with Azure Automation. So building stuff in general can be a fun exercise. It's nice, it's collaborative, but when you're building anything, a PowerShell module, a car, a house, something that you need to consider is that things can also go wrong, and it doesn't always go the way you want it to go. So what I'll be trying to do in this session is cover some of the design considerations when building PowerShell modules in general, but also when you're using PowerShell modules in combination with Azure Automation. Before I go further, this is me, I'm Jaap. I occasionally do things with PowerShell, or maybe more than occasionally. I'm a developer advocate at Rubrik. If you need socks, if you have cold feet, come to the front of the stage at the end. I have some swag, so swag is always good. And I like quokkas, because quokkas are quite happy, and someone at Rubrik decided that I was in charge of naming projects, so obviously I named my project Quokka. There will be a picture of a quokka later on. So what we'll be covering today, I already briefly touched on it. I'll be talking about PowerShell module development, like how do you get started, what kind of things do you need to consider. Then we'll talk about how it will work in combination with Azure Automation. So I got some demos, not interactive demos, and at the end, I'll stick around for anything specific PowerShell or Azure Automation related. So let's get started with PowerShell module development. When you get started with developing a module, obviously you need to have a goal. There needs to be a purpose for the module. Creating a module in PowerShell itself is something that's relatively simple. You can just take an existing script file, rename it to PSM1, so a PowerShell module file, and from that moment on you're able to import it and use it and distribute it as a module. But there's of course more that you should consider when you create a module in PowerShell. So one of the things that shouldn't come as a surprise is whenever you're writing any kind of code or any kind of configuration, use source control. Doesn't matter if you use Git or Team Foundation Server or any other version control system, but you need to have some kind of version control. And having version control also makes it easier to collaborate with others, because if you're just creating script files and dumping them on a network share and incrementing the version, after a while it's going to become quite hard to manage. And I've been the guy that dumped it on the network share, so I know how hard it gets to manage. So version control is a big thing, and this also allows you to share your scripts. So in the case of PowerShell, sharing your scripts is actually very easy because there's something called the PowerShell Gallery, and the PowerShell Gallery allows you to upload your modules and also upload your scripts. So anything you've created in PowerShell, you can share this in the PowerShell Gallery. So the next thing, once you get started with your module, you've decided on which kind of version control to use. You need to be able to validate. You need to be able to validate your code. You need to be able to validate that your code is going to work. So this is a general workflow that I follow. I write some code. I validate that it works. So validation in this case can be as simple as execute your code and see if you get the result. But for some of the more destructive commands, you wouldn't want to actually run a command. So when you have commands like that, you can write unit tests. And one of the frameworks we have in PowerShell is called Pester, and we can use Pester to write and to run your unit test. And if your code is ready for production, you can commit it into the repository and you can actually execute it against your environment. So this is a very broad overview of developing a module. So what kind of considerations should we have whenever we're developing a PowerShell module? So when you're sharing your code, or even just if you're the only person running your code, you need to be able to troubleshoot your code. Because at some point, something is going to fail. And it might not be the code that you've written, but it might be an external program you're calling. You might be doing a web request and the web server is down. So you have to be able to see what is going on when something is going to go wrong in your code. And this is already the case when it's just you, but when it's other people running your code, generally you cannot see exactly what they see. They might be able to share their output, but if we don't have any kind of verbose output or debug output, we still don't know what's going on. So I'm a big fan of the write verbose commandlet. Does anyone here ever use write verbose in their scripts? Can I see some hands? Perfect. Preaching to the choir, I like that. The next step is actually writing unit tests. I'm just going to ask the same question again. How many of you have actually written a unit test? Pretty good, pretty good. So writing unit tests is something that doesn't always seem logical. The first time you're writing a unit test, it's like, what should I be running? Because I have this script, I know what it's supposed to do, I know it's going to work. So why should I write tests for my code? So if after getting over this initial hurdle and understanding at how you can test a specific part of your code, you will have an easier way of being able to validate that the code that other people are submitting to your project, to your module, actually works the way it's supposed to work. All right. And the next one is actually document your code. In PowerShell, we have something called command-based help. And command-based help actually makes it very easy to write documentation and be able to leverage the get help commandlet. So writing documentation is something that's very important. And the nice thing is that if you actually create this command-based help, you can also extract this directly from your PowerShell module, and you can export it to other formats. So for example, we can export it to Markdown, and if you have it in Markdown, it's just one step away from converting it to a PDF, which you can distribute, or to automatically generate online documentation. So documentation is a very important thing, and the two things that I always include whenever I document anything is I'm going to make sure that there's going to be a synopsis or a description of the function, so people can see, okay, this is what it's supposed to be doing. The second one is provide an example. An example should be relatively easy, because if you're writing your code, at some point you're going to execute your function or your script. So whatever you executed, copy that in there, put it there as an example, and write a short description about what this is supposed to achieve. And by doing so, you make it easier for someone that has never seen your function or doesn't know what it's supposed to be doing to actually understand what you're trying to achieve. And I've actually helped myself with this, because I don't write a lot of code, but I write enough code that if I come back to my own script after a couple of months, I don't know what it's supposed to be doing anymore. I probably should know what it's going to be doing, but many times I just don't know. So documentation, it has saved me many times. So it's not the hottest or the coolest thing to be talking about, but it's very important. So a short demo, or actually a short video of what verbose logging would look like if you make it part of your code. I have an example script. I'm going to gather some information about some virtual machines, but I actually want to see what is happening, so I include the verbose switch. So let's see if it's actually going to be running. You can see I have the command there, I specify verbose, and you can see we get a whole bunch of verbose information. And this information can be used whenever you need to troubleshoot your script or you want to see what kind of calls were happening. You have this verbose information that provides this. Moving on, Azure Automation. So Azure Automation, if you don't use it for anything else, it's a fantastic orchestration tool. It's kind of like a task scheduler, but on steroids, because it can do a lot more. And unlike the task scheduler, Azure Automation runs in Azure, so you don't have to worry about if my one management machine is down, are my scripts still going to run? Also, if I'm running a script, where are the log files? Are there even log files? And if your server would die, you just don't have any information anymore. Aside from just orchestration, it can also be used for configuration management or update management. So it's a very powerful tool. And if you do anything with scripting, I highly recommend looking into it. So one of the core strengths of Azure Automation is the fact that it's cross-platform. So you can use it not only to manage your Windows or Linux workloads in Azure, but also on premises. It has support for external modules, and it comes with a lot of modules already included. There's something called the hybrid runbook worker, and this is something that you can actually run on premises. So if you want to execute any of the, as it's called in Azure Automation, a runbook, you can run it by using a hybrid runbook worker. And this is something that you can install using a PowerShell script. It connects back to Azure, and then it just waits for a command or a task for it to be executed. So coming up next, let's see. If we want to actually create a runbook, what I'll do now is I'll walk through the steps and the kind of things we need to consider whenever we're creating a runbook in Azure Automation. So creating a runbook is pretty straightforward. If you go into the Azure portal, and in these examples I'll be using the Azure portal, you can navigate to Azure Automation, create a runbook, and this is the kind of screen you would see. So for the runbook type, we can specify whether we want to use PowerShell or Python or some other automation language. I like PowerShell, so I write my scripts in PowerShell. So once we have our PowerShell runbook in this case, we can start and put the code in there. So whatever we want to execute, whichever functions we want to call, we can enter it in here. So I already mentioned that there's a lot of modules already included. So here's a short overview of a couple of the modules. So we can see we have the Azure RM modules. For anyone who's familiar with the PowerShell, with the Azure PowerShell module, these are actually the old Azure modules, because right now we have the AZ module. AZ module also is compatible with Azure Automation. But the nice thing is, and you can already see it here, you can also include your own modules. So if you've created your own modules, what you can do, you can click Add Module, and you can see here, we can upload the module as a zip file. So in this zip file, at a minimum, it should contain a PSM1 file, but you can also upload an entire file or folder structure which contains your module. And after uploading it, you will have the module available. So this is one way we can do it to the web interface. Another way is to use the new Azure RM automation module commandlet. And with this, we can specify a URI that contains the zip file, and we can upload it directly to Azure Automation. I already mentioned that there's a PowerShell gallery, And the PowerShell Gallery actually provides us with an even easier way of getting our modules into Azure Automation. So here we can see the rubric module. So this is one that I've actually done a lot of work on. And if we want to import any module that's available in the PowerShell Gallery, we can also do this directly from the web portal in Azure Automation. And we can, in this case, I look for rubric, and we can see all the modules that are available in the PowerShell Gallery that match this name will come up. So to summarize, whenever you're writing code, make sure that you use source control. If not to collaborate with others, just do it for yourself, because the amount of times that I accidentally made a change to code, just saved it outside of source control, and then kind of forgot what I did. Source control is a big lifesaver. Validate your code. So either by running it yourself, providing verbose information, or by creating unit tests that validate that the code executes as you would like it to execute. Next up, log your actions. So whenever anything is happening in your module, in your functions, in your skits, make sure that there's some kind of logging. Whether it's verbose logging, whether you provide output to the user, make sure that it is logged. And use this to automate any step you have. And if you do all these things, you'll be just as happy as the quokka over here. So for those of you who don't know what a quokka is, this is a quokka. They're amazingly cute. They're very happy. I like to look at them. That's what I do. Thank you very much. I'll be hanging out.